Okay, so the next section, 5.1, is the graphs of reciprocal functions. We're going to look at what happens to the reciprocal function and how do you graph a reciprocal function based on the original. There's going to be two types of questions we're going to do. One is when there is a linear equation and when there is a quadratic equation that's part of the reciprocal. So first we're going to look at is the original graph. F of x is equal to 2x plus 1. So a linear function that's 2x plus 1 would be starting at 1, the y-intercept is at 0 and 1, and then it goes up to right 1, up to right 1, and then you have your line. What we are going to graph, right, we are going to graph g at x, which will be 1 over 2x plus 1. So it's the reciprocal of 2x plus 1. When you are given the graph, your process is very straightforward. If you have the graph and you don't have any other equation, or you don't have any other information on it, wherever it crosses the x-axis, like here, you will have a vertical asymptote. So I'm going to draw a vertical asymptote wherever my function crosses the x-axis. The reason for that is where it crosses the x-axis, the y is 0. So we have 1 over 0 as the denominator, which is undefined. So you'd have an asymptote. The second thing we want to look at is wherever y is equal to positive 1 and negative 1 on the original function. So on my original function, y is equal to 1 here, and y is equal to negative 1 approximately there. These 2 points where y is equal to 1 and negative 1 will also be on the reciprocal function. So on my reciprocal function, I will have to go here. To figure out the rest of the graph though, you look at what the trend is happening. From the, between the y equals 1 value and the x-intercept or the asymptote, all of these y values will be decimals. So if you take the reciprocal of decimals between 0 and 1, they will get larger and larger. Therefore, my graph will go up. And if I take values beyond this y equals 1, my graph is going up, so the reciprocal will be going down. And the same would apply here. Between this y equals negative 1 and this y equals 0, the y values between this point and this point are all going to be decimals between 0 and 1, or between 0 and negative 1. If we take the reciprocal of it, for example, if let's say there's a point that's the y value is negative 0.1, the reciprocal, or 1 over negative 0.1, would be negative 10. So it actually becomes larger. So all the values between the asymptote and the y equals negative 1 are going to get larger. And everything to this side will go here. Okay. Let's apply the same thing again for negative 2x plus 4. We are going to graph g at x is equal to g at x is equal to 1 over negative 2x plus 4. Instead, for this question though, we are not going to graph the original function. We're just going to look at what values we know. The first thing we need to figure out is where is the y value equal to 0. So we can plug in a 0 into this equation. We'll have 0 is equal to negative 2x plus 4. Negative 4 is equal to negative 2x. And x is equal to 2. So I know that at x equals 2, I have a vertical asymptote. Okay, that was the first step. I found the x-intercept. Now the second step is I want to find out where is y equal to 1 and negative 1. So I'm going to plug in 1 for the y value and get negative 2x plus 4. Take the negative 1 to the other side. So 1 minus 4. So I take the positive 4 to the other side. 1 minus 4 will be negative 3. Negative 2. If I divide it, we'll get x is equal to 3 over 2, which is 1.5. So at x equals 1.5, the y value will be 1. I have my positive 1 value. Then I'm going to do the same thing, and this time I'm going to find it for negative 1. Because I want to find out where's y equal to 1 and where's y equal to negative 1. Negative 1, take the 4 to the other side, it'll be negative 4, that becomes negative 5, equal to negative 2x, and x is equal to 2.5. So at 2.5, it will equal to -1. Those are the three main points I want to find. Where is it equal to 0? Where is it equal to +1? And where is it equal to -1? Now that I have those, I can get the general shape of the graph. I know that in between these 2 points, it's going down, so my function will go up because those are all decimal values. Same thing here. We have the general shape, and you get your reciprocal of the linear function. Let's look at now the reciprocal of quadratic functions. Okay, so we have our function f of x equal to x squared plus 2x minus 8. The reciprocal function, which I'm going to denote g at x, will be 1 over x squared plus 2x minus 8. Now, when it comes to quadratic functions, the easiest thing to do is to get the base graph first, figure out what the original function looks like, and draw your reciprocal based off of that base graph. It will not be exact, but a sketch is adequate. So in order to figure out what the graph would look like, the first thing we need to do is to factor this. This will be two numbers that multiply to be -8 and add up to be +2. Will be x plus 4, x minus 2. And from there, we can draw our graph. So I know that there's a 0 at -4 and at +2. I know it's a parabola opening upwards. And I know that if I do -4 plus 2 and get -2, divide that by 2, get -1, the vertex will be at -1. If we plug -1 into our equation to find out the y value, -1 plus 4 is 3, -1 minus 2 is -3, and we have -9. So there's your vertex, which will be at -1 and -9. Once I have my points, I can go ahead and graph my parent function parabola. Now we can go through the same process that we went through with the linear function. Step 1 is we want to find out where does the graph equal 0, where is the y value equal to 0, or where are the x-intercepts. So we have an x-intercept here and here. At the x-intercepts, we know we have asymptotes. So I've drawn my two asymptotes. The second step now is to identify where is y equal to 1 and -1. So we'll approximate y is equal to 1 here and here, and then it's equal to -1 here and here. So I have my -1 values and I have my +1 values. On the outside, it's very straightforward. Because the original function is going down, the reciprocal will be going up here and there. Same thing here. We have the general hyperbolic shape of our graph on the outside. On the inside now, there's a slightly easier way to do this, is to understand that the vertex is the lowest point of our parabola. So if I did the reciprocal, it would be the highest point of the reciprocal function. So if it's at -1, -9, the reciprocal would be, I'm going to erase this for a second. It would be here, and that would be at -1, because the x values don't change, and -1 over 9. So obviously we're going to approximate that and say that's -1 over 9. The rest of it now is just combining, joining the dots and getting a general shape. We know that at the asymptotes it's approaching the asymptote but not quite touching. So that's how we would do the reciprocal of a quadratic function.